All right, guys, this is your lesson on earthquakes. So, we've been talking about the structure of Earth. We've talked about Earth's layers and how the plates are floating on top of Earth's mantle. Um, so, now we're going to talk about specifically earthquakes because earthquakes happen near these plate boundaries. They can also happen at cracks in the plates. So, we'll talk a little bit about that as well. Okay. So, the first thing I want you to do is write and answer these questions. You can either do it on Google Docs or in your notes as you take notes for class, but I do want you to go ahead and pause the video so you have a chance to answer these questions. All right, now that you've had a chance to answer them, most of you probably haven't really experienced a big earthquake. If you have felt an earthquake, it's probably been a small one. I could be wrong. I know that around here we don't get huge earthquakes very often, if ever. The most recent one that I know of that people were able to feel was only a couple years ago, but it was very, very small. There was no damage from it. But if you've ever experienced an earthquake, you know what we're talking about when we talk about huge earthquakes. We know what the damage looks like, okay? So it's part of what we're going to talk about today. All right. And the second one, all right, what are you supposed to do in an earthquake? All right. So I'll go ahead and tell you the answer to the second part of that question. Is it different if you're inside or outside? And it absolutely is. So there's different things that you're supposed to do inside versus if you're outside. Okay. If you are inside, your best bet is to get underneath a table or stand in a door frame that you know is going to be really sturdy. Or if you have a very small closet that you know is near the middle of your house or near a supportive beam in your house, that's one of the best places to be. Okay. And the reason you want to be under something that's supportive, something sturdy, is so that if something does collapse, if something does fall off the ceiling or anything like that, that you're protected from it as best you can be. Okay. Now, if you are outside, it's a little bit easier to stay safe. Now, if you are inside and you know that you can get outside really quickly and you know that you're not near any tall buildings or anything, then being outside is going to be a better bet. So if you're in your house and you know that you have a yard that you could go stand in, that would be one of your best bets. Okay. So if you are outside, you want to be away from buildings, you want to be away from trees, you want to be away from vehicles. You just want to be in an open, flat area if that's possible. Okay. Now, granted, some of you have probably seen movies where they show like the huge cracks opening up in earth, and that's not impossible, but it's not very likely. So it is your best bet to be outside, but if you do see a hole opening up, like a sinkhole or like a crack in the earth, you do want to stay away from that. Okay. So it's very simple what you're supposed to do, but it's just kind of making sure you know what's supposed to do before it happens so you don't freak out in the moment and not know what to do. Okay. So that's what you do if you're inside or outside during an earthquake. Now let's kind of dig into what earthquakes are and what that looks like for us. All right. So this is the title for your notes today. We are talking just specifically about earthquakes. All right. First thing, and we've already talked about this, earthquakes are caused by the movement of tectonic plates, and they can happen at plate boundaries or near fault lines, and fault lines are cracks in Earth's crust. Okay. So there is a fault line running from Lancaster County all the way through down to Charleston. So it runs through Columbia and into Charleston. All right. Now, there are others, but that's just the closest one to us. And I mean, there's not been a whole lot of activity on it. The most recent one that caused a whole ton of damage that even was like newsworthy, that was causing problems within the 1800s. So I really don't think that it's going to be a huge issue for us, but we are very close to a fault line. Okay. So it is a possibility, and earthquakes are not something that we can predict very easily, if at all. All right. So we haven't had one since the 1800s. So, in all honesty, I don't know that it's going to be a huge issue for us, but there is always that possibility. And it's not like a hurricane or a thunderstorm. We can't see them coming. We can't see them form using weather radar. We can't see down into the ground to see what's going on necessarily, not as far as earthquakes. Okay. So it is not something we can predict, but we know we're near areas where they can occur. All right. So now we need to talk about where they begin. Now, the spot where it begins underground, so where that pressure is released from, or where that tension is released, we talked about the tension when we talked about the plates moving. So wherever that tension is released underneath the ground, wherever it catches and then lets go, we call that the focus. All right. Now, The spot on the surface of Earth above the focus is called the epicenter. So the epicenter is where the earthquake begins for us. Now, the earthquake can happen underground and shift and move and change, and we might not ever feel it at all on the surface of Earth. So the focus is where that earthquake actually starts, and then for us on the surface, the epicenter is where that earthquake begins. That's where we can feel the strongest tremors from the earthquake. All right. Now, when we talk about that shaking that's caused by an earthquake, we call it seismic waves. So if you ever hear seismic, they're talking about earthquakes. All right. So now let's talk about those seismic waves. There are different kinds of seismic waves. So the first kind of wave is a primary wave. We talk about primary being first all the time. It's the most important. That's what primary means. So primary is that first kind of wave that's going to move from the earthquake. They're moving out from the focus and they're going to travel the fastest. So if you're not right on top of the epicenter of the earthquake, then you're going to feel the primary waves first. If you're on top of the epicenter, you won't really be able to tell much difference between the types of waves. But if you're farther away from it, the primary waves are going to be the first waves that you feel. And that's because they travel the fastest. And they travel through the solid and liquid layers of Earth. That means they travel through the crust and through the mantle. Okay? All right. And these are going to push and pull on the rocks as they travel, creating a back and forth motion. So if you've ever been on a treadmill or, what do they call it? Like the moving sidewalks they have at airports and Disney World and stuff like that. That would be what I'm talking about. They're moving side to side. So they're moving right in line with the flat plains of Earth that we're standing on. Okay. All right, now the second kind of wave we're going to talk about is secondary. So we have primary first and then secondary next. Okay. Oh, and I do want to point out when we talk about primary waves, we will say P waves. So primary waves or P waves, just to kind of save us a little bit of time. And then secondary waves or S waves. All right. And these, just like the primary waves, move out from the focus, but these move slower. Okay. But they're going to shake the ground harder. But these only move through the crust. So they're not getting to release any of that energy into the mantle. And that's just because of the way the waves move. So the secondary waves, they move a little bit slower, but they're going to shake the ground harder. So it's like a stronger vibration. All right. And these are moving out at right angles to the primary wave. So they are going to make the ground move up and down and not just side to side. Okay. So they can move in both directions. They can make the ground roll like an ocean, like you see my cursor doing. Whoops. They can make the ground move like you see my cursor doing, up and down that way, and move side to side just like the primary waves do. Okay? All right, now, the third kind of wave we're going to talk about. This is not, please don't get this confused with S waves. I know it starts with the same letter, but it's either S waves, P waves, or surface waves, because surface waves is either or. It can be S waves or P waves, but these are the waves that reach the surface of Earth. So when we talked about that focus being underground, if those waves never make it to the surface of Earth, we have no surface waves. Okay? But once those waves reach the surface of Earth and we can feel that shaking, then we call those surface waves. And since it is S and P waves, then it can make the rocks roll like the ocean or move side to side this way. Okay? All right. So now we need to talk about measuring earthquakes and figuring out where they started. That's one thing that we can't predict. So we have to look back at data and figure out where they started after the fact. Okay? All right. So earthquakes are measured by using a seismograph or a seismometer. So that's the same kind of tool, but they have two different names. And then the record, the paper readout from a seismograph is called a seismogram. And I want to help you remember that the seismogram is a piece of paper. It's the piece of paper that comes out of the machine. You remember the candy grams that we used to sell at the school, right? So you could buy one for Valentine's Day, for Christmas, for I think we did one for St. Patrick's Day one year too. But anyways, it was a card that you could buy to send to somebody in another class or even to yourself. And you would write their name on it, they'd stick a piece of candy on it, and then they would send them that card. All right. So a seismogram is kind of like that candy gram. It is a piece of paper that comes out of that machine. Okay. All right. And then to figure out where the earthquake started, they're going to use a process called triangulation. And we'll talk a little bit more of that in a second. But means 3. So we would need 3 locations to figure out where the earthquake started. And we're using triangulation. You are finding the epicenter of the earthquake. You're finding where it began on the surface of Earth, so where it began for us. All right. So now, triangulation uses the time it takes for waves to reach 3 separate points. We talked about that already. Tri means 3, so triangulation needs 3 points. And the reason we need the 3 points is because we're trying to find exactly where it started. And I'll explain this just a little bit better in a second. Okay. All right, so the difference in arrival times for the S&P waves at a certain spot can tell scientists how far the epicenter is from that given point. Okay, so they're using math to figure out how far away the earthquake is from one given point. We talked about how the primary waves travel faster. We know how fast those travel. We know how fast the secondary waves travel. If we can figure out the difference in the arrival times, it'll tell us how far away the earthquake is. Okay, or how far away it was when it started. So we'll be able to find that epicenter. Okay, so I am going to really quickly explain this. Explain this, kind of draw it out a little bit for you. Okay. All right, so we're going to pretend like we have. All right, let's see. We're going to have 3 points. We're going to have point A, B, and C. So right here will be point A. Here will be point B, and we'll put C right here. So A, B, and C. Now, if we know, doing all our math and giving all that out, that point A is, we'll say point A is 10 miles from the epicenter of the earthquake. And we'll say point B is 5 miles from the epicenter of the earthquake. And I don't know. Let's see. Actually, I'll tell you C in just a second, just to make sure it actually works, so I can give you that example. All right, so if I know point A is 10 miles away from the earthquake, I don't know what direction it's 10 miles away from the earthquake, but I know that it's got to be 10 miles away. So making something that shows 10 miles away from a given point. I'm going to do this in a different color so you can see it a little bit better. All right, so making a shape that shows 10 miles away from a given point in any direction means we're going to be drawing a circle. Okay, so I'm going to draw that's my radius for my circle. So it's 10 miles away in any direction. Okay, so I'm going to go ahead and draw my circle around point A, and it's not going to be perfect, but I'm trying to give you an idea of what that would look like. Okay, and I know it's not perfect, and I'm not going to finish the whole circle because we're not going to use the whole circle. All right, so we'll say that point B is still that 5 miles away. So I'll do a radius of, we'll say 5 miles. And this isn't going to be perfect, but that's okay. I'm going to draw my circle. Okay. And we'll say that point C is, I don't know, 3 miles away from the earthquake. We'll call point C at 3 miles away. Okay. Okay. All right, so if point C is 3 miles away, I'm going to use that, draw my diameter, and see where they meet. Okay, now I have drawn all 3 of my circles. I've got the diameter for all 3 of them, so I know that my earthquake occurred, or the epicenter of the earthquake is right where those 3 circles meet. Now, in this case, it looks like A and B are really close to each other, just in that one area. But to make sure that we know exactly what we're looking at, we need that 3rd point, because in some cases, they're not going to be that close. All right. So you need those 3 points. You need to be able to say it is exactly where it belongs. Like, you need to be able to say that's exactly where it was. And to do that, you need the 3 points. And that's why we call it triangulation. Okay. Okay. All right. Now, one last thing. I've got a really neat clip that I am going to share with you. Okay. So this right here is some video footage from Japan that shows what a major earthquake looks like. Okay. All right. So I'm going to go ahead and play this. And you can see carefully if you look right where my cursor is here. If you look at the building compared to the horizon, you can see the building swaying. Okay? And we talked about the technology that's in this building when we talked about the NASA technology. They have that shock absorber stuff installed near the bottom of the building. So that's why the building is swaying and not just crumbling and falling. And you can see this, I think it's a sign. You can see that thing swaying too as the building sways. So you can watch it move. And it's really easy to see when the buildings are next to each other because you can see them getting closer and farther and then closer and farther. Right. Now, if we look at this, you can see a crack in the ground here. You can see it moving.
The crack is getting bigger and smaller, going back and forth.
Yep.
And there's water coming up all over in the park right now. This crack is just moving. There's water. I don't know if water lines are broken, but this water was not there a minute ago.
Okay. There's another spot where you can see the crack moving.
And it's still moving. It's just going back and forth, swaying.
Alright. And this is another one where you can see the ground kind of moving. If you look at the crack in the two different kinds of cement here on the sidewalk, you can see it shifting every once in a while. If you watch that crack in the cement right here, between the two different kinds of cement, you can see them shifting. I think some of these people are trying to get out of their work buildings or get out of these buildings that are around them. I don't know if it's grocery stores or what. But I think they're trying to get out of those buildings and find a place to wait and see if anything's going to get worse or whatever. All right. So when we talk about earthquakes, we talk about things happening. They might not be huge for us. It might not be something that we worry about a whole ton. But earthquakes are a serious natural disaster. They can be huge. They can cause some really awful problems and some really nasty damage, some bad things for us to have to deal with. But for the most part, where we are fairly safe. But it is something to keep in mind. Okay. So we just talked about earthquakes. We talked about how to figure out where they started, how to measure them. We'll dig in a little bit more about how to measure exactly how strong they are. But that's for another lesson because I don't want to get super in depth in that while we're talking about what the earthquake itself is. Okay. All right. So we've already talked about earth layers. We talked about the earthquakes that happen at the plate boundaries where those plates are shifting around. We talked about what an earthquake is and what that looks like today. All right. And you'll have an activity for the class after the lesson. Make sure you're double checking that on Classroom. Okay. And that's it.